So now, as we've looked at chemical reactions, we want to be able to write down a chemical reaction, and we call this a chemical equation. So it communicates the reactants involved, which are the substances that are reacting together, and the products that form. And so, in order to write a word equation, let's look at an example. So to begin, we're going to write a chemical equation just in words. So we're going to start with the example of magnesium metal reacting with hydrochloric acid. Now we know that there's a chemical reaction occurring between magnesium metal and hydrochloric acid, and so we can write the reaction down first as a sentence. So we'll say solid magnesium metal reacts with aqueous hydrochloric acid to produce aqueous magnesium chloride and hydrogen gas. So this is just a description of the reaction itself. This is just a sentence describing what happened. So first of all, let's take a look at what our reactants are. Well, our reactants, we have solid magnesium metal is going to react with aqueous hydrochloric acid. And what are our products? Well, our products are aqueous magnesium chloride and hydrogen gas. So we've identified our reactants, we've identified our products. And the word equation can then be written to introduce us to some important symbols. So, let's write this down. So we have magnesium, and that's going to react with hydrochloric acid, which gives us magnesium chloride and hydrogen gas. So as we've written this, you can see that we've introduced a few symbols. And it's important that we understand this. So when we're saying and listing our reactants, well, we're not going to list them, using commas where you have a plus sign. Right? We're using a plus sign to show that magnesium plus hydrochloric acid is going to give us something else. It's going to give us magnesium chloride plus hydrogen gas. However, the key difference is you'll notice that we have an arrow here, and this arrow signifies a change from our reactants to our products. Now note, we are not using an equal sign. An equal sign does not work here because equal signs in math suggest that an equation works one way as well as the other. Whereas in this case, we're not saying that magnesium and hydrochloric acid give us magnesium chloride and hydrogen gas, and then right away, these guys can also give us this. Because when we're talking about chemical reactions, it's important that we discuss the direction that it's going from reactants to products. So we use an arrow and not an equal sign. Now, when we're writing chemical equations, we want to be able to write them not only using words, but also using the formulas. And we call this a formula equation. So we'll start with a really, really simple equation. And this is an example of where some city transit buses, they use electricity produced by a fuel cell. And electricity comes from a reaction between hydrogen and oxygen to form water. So the reaction can be described just using words by simply as saying hydrogen plus oxygen gives us water. Now I'm writing my reactants in a different color than my products to be able to show that they are different. So this is, again, just an example of a word equation, but we want to be able to write a formula equation. So a formula equation uses the chemical formula of the reactants and the products in a chemical equation to represent a chemical reaction. Now remember, oxygen and hydrogen gases, they both exist as diatoms, so they're both diatomic molecules. So the formula equation would look something like this, where we have hydrogen gas, number 2 because it's diatomic, plus oxygen gas, gives us liquid water. So here we have a formula equation. So it's the same equation, but now we're using the formulas of each of these substances rather than just the words. But this is what we call a skeleton equation. So it only tells us which substances are involved and what elements are present, but it is limited because it does not show the correct proportions of the reactants and products. Because even if we just look at this, what this is telling us is that we have 2 hydrogen atoms reacting with 2 oxygen atoms, giving us 2 hydrogen atoms and 1 oxygen atom. According to this equation, we're missing an oxygen atom somehow. So remember, the law of conservation of mass says that the mass of our reactants has to equal the mass of our products. And so far, just according to the numbers of atoms that I can count, that's not going to work out. So we need to be able to show the proper number of reactants and products and show that it equals out. So this is called writing a balanced equation. So the balanced equation for the formation of water looks a little bit different. We still have hydrogen gas reacting with oxygen gas to give us water. However, we need to make sure that we show the proper numbers. So that looks like this. A balanced chemical equation uses coefficients like this, as you can see, in order to show how many of each there are. So as you can see now, we've added these coefficients. I have 2 hydrogen gas molecules reacting with 1 oxygen gas molecule to give me 2 liquid water molecules. Now if I look at just the atoms involved, this tells me that I have 2 H2, which means I have 4 hydrogen atoms reacting with 2 oxygen atoms to give me 4 hydrogen atoms and 2 oxygen atoms. Because this coefficient of 2 is for all of this. So that means I have 2 waters, which means I have 4 hydrogen and 2 oxygen here. So now the number of atoms on either side is equal. So this shows that law of conservation of mass.